Okay, lines, page 6, number 3. A line has equation. This looks a little bit different than normal. Write the equation in the form y equals mx plus c. Okay, so let's just multiply everything out and maybe that'll help. So instead of 3x minus 3 times quantity x minus 6, we'll put 3x minus 18 over 2. Now we'll divide both terms by 2. So we'll have 1.5x minus 9. And there we go. We're already in form y equals mx plus c. M is obviously 1.5. C is negative 9. Write down the gradient of the line. Well, we just found out it's 1.5. Write down the y-intercept. We just found out it's negative 9. Find the point of intersection of the line with the x-axis. Okay, now we just figured out how to do that on the calculator, right? So we could put, let's see, in the calculator here, 1.5 x minus 9. And then we're going to graph it. And then we're going to go second calc. 0. Left bound. Where's my cursor? There it is. Here's fine. Doesn't really need to be perfect because we only have one intersection anyway. That's my guess. So x equals 6. Actually, the form they gave it to you in kind of made it easy to do it by algebra. If you wanted to do this one by algebra, look at this equation here. You could say, hey, when does y equal 0? Which is basically where is the y-intercept, or the x-intercept? And you can see that to make this 0, all you need to do is make this 0. So if you put x equals 6, that would make it 0. So guess what? That was the answer. Okay? But you could do it with the calculator too. Okay. If you put the coordinates of 2 points into the list L1 and L2, you can find the line equation through them with StatCalc LinReg. We've been doing that already quite a bit. So the line AB joins the points 2, negative 4 and 1, 1. Find the gradient of AB. And find the equation in the form y equals mx plus c. Well, remember, the calculator just does this all in one shot. You just give it those 2 points, and it'll find both the gradient and the equation. So we'll do that. 2, negative 4 and 1, 1. 2, negative 4, 1, 1. And the gradient stat, calc, linreg, L1, L2, calculate. So we have negative 5x plus 6. Y equals negative 5x plus 6, and we know that the gradient, of course, is negative 5, which is right there. Okay? Next one. PQ joins the points 1, 3 and 2, 5. Stat, edit. We'll put those points in here. 1, 3, 2, 5. Graph. Okay. Not graph. Stat, calc, linreg, L1, L2, blank, calculate. 2x plus 1. So the gradient is 2. The equation is y equals 2x plus 1. The gradient of all lines perpendicular to PQ. So if the gradient is 2, then the perpendicular to PQ would be negative 1/2, negative reciprocal. Find the equation of the line perpendicular to PQ that passes through 0, 2. So now we know that we want a line that goes through 0, 2, and it has gradient negative 1/2. So let's try to use algebra to do this. Okay, we could do this by graphing, but so we know that m is negative 1/2. We don't know what c is, but we do know one combination of y and x which makes c the right number, which is 0, 2. So what if we put 0 here and 2 here? That'll say negative 1/2 0 is 0 plus c. Oh look, c is equal to 2. Actually 0, comma 2 is a line, is a point on the y-axis, and c is the y-intercept. So that makes sense that c equals 2. Okay, so the equation is going to be y. We need to put the y and the x back into it because without the y and the x, it's not the equation to a line. Okay, so that's the final answer. Number 6, line L1 has gradient 3 and is perpendicular to L2. Write down the gradient of L2. Well, gradient of L2 is the negative reciprocal of the gradient of L1, so it's equal to negative 1/3. L2 passes through the point 5, comma 1. Find the equation of L2. Give your answer in the form y equals mx plus c. Okay, so we could use algebra to do this, just like we did last time. We do y equals mx plus c. M is negative 1/3. Negative 1/3 x plus c equals y. And we do know that one valid point is 5, comma 1. So if we put a 5 here and a 1 here, we would get 1 equals negative 5/3 plus c. C is equal to 1 plus 5/3, which would be 8/3. Okay? 8/3. All right, and so the equation over a line, we'll put the y's and the x's back into it. So it'll be negative 1/3 x plus 8/3. Okay? All right, and that's the equation for line 2. Find the x-coordinate of the point where L2 meets the x-axis. Okay, and remember that there's a couple ways to do this. One is you set y equal to 0, and you figure out what x is going to be then, or you could use the calculator function. So we're going to put negative 1/3 x, negative 1/3, negative 1/3 x plus 8/3. Okay, and then we're going to see where that crosses the x-axis by using the second calc function. Enter. Enter. Yes. So it's 8, x equals 8. Okay? All right. Last of all, find the equations of these lines in the form y equals mx plus c. Okay, so here we could see that the slope is 1 divided by 1. So it's y equals 1 divided by 1, x plus, and what's the y-intercept? It's 1. What about this next one? Y equals, and then the slope is rise negative 1 divided by positive 1 run, so it's negative x plus 1. Okay, and then c, let's see, we got okay, so rise negative 1 divided by run 2, and then the c value is negative 1. So negative 1/2 x plus a negative 1. Okay, so those are the 3 equations there. You just use the y-intercepts and the slopes, which you can calculate just by counting blocks. And that's it.